Hey guys, good morning. Welcome to Math in the Morning. I missed yesterday because I had a big cloud around my head and I was like, what am I gonna do? How am I gonna do all this stuff? I had a big cloud, so I was like, you know what? Take the nothing option. Okay. But I think sometimes it's like I sort of got my mind organized and I was like, okay, I know what I'm gonna do this week. I gotta get through this stuff, you guys, because I do have to go back to work next week and I got my schedule and stuff. And like I said, I'll save all the. I'll just say I'm going to be working like kind of like full time. Like I'm usually working as like a professor, which like I have a couple classes. This is like I actually have to be there like every day. I don't know. I'll talk more about that at the end if we have time. Okay. So anyway, I don't know how much I'm going to be getting done. As far as I'm going to get the slides done this week, and then understanding, that's going to be the fine tuning of the understanding and the explaining. That's going to come. Anyway, I'm so excited to share these slides with you. Okay, so I got my new outfit on, so I'm kind of like checking myself out. Okay, so we got these slides. So today, so the first slide, theorem, if kappa is immeasurable. So, the proofs are always the hardest part, but they're also the most fun part. Okay, the most like satisfying and fun part. Okay, so this is about the measurable cardinal case. Okay, if kappa is a measurable cardinal, then there's a forcing extension where the order of kappa is 1. The forcing will preserve all measurable cardinals and not create any new measurable cardinals. So I'm just going to go through a little bit of a proof outline of the most basic case, which is just that you have a measurable cardinal. It might be any rank, any degree, and then you go to a forcing extension where it's just measurable. It doesn't have any extra rank. It doesn't, there's no like elementary embedding where it's a critical point, and then it's also measurable in the end. No, it's just measurable and that's it. Okay. So the question might be, can forcing create large cardinals? Yes, it can. Measurable and inaccessible and model cardinals are downwards absolute. So like if you're in a forcing extension and you're like exploring and you see a model cardinal, well, that model cardinal already had to be in the ground model. But that's not true for other large cardinals. So you could create a measurable cardinal, but thankfully, we have Hampkin's paper and all his work on this kind of topic, forcing in large cardinals. And so in particular, we have Hampkin's paper, extensions with the approximation and cover properties have no new large cardinals. So especially this paper covers a lot of different types of large cardinals, and specifically the one for my paper that I need for these proofs that we need is corollary 22, especially. Suppose V subset of V bar satisfies the delta approximation and cover properties, then every measurable cardinal above delta in V bar is measurable in V. Okay, so it doesn't create new measurable cardinals. Okay, let's go to the next slide. Okay, so this is a main lemma. This is sort of like the preservation part. And again, back to the delta approximation and cover properties. So the main lemma in this work with measurable cardinals killing them softly is if V subset of V of G is a forcing extension in every normal ultra power embedding J from V to M in V with critical point kappa lifts to an embedding J V of G to M of J of G, then the order of kappa in V of G is greater than or equal to the order of kappa in V. And if V subset of V of G also has a delta approximation and delta cover properties, then the order of kappa is the same in the forcing extension as it was in the ground model. And so this delta approximation and cover properties put like a little element of realism. This is from Joel Hampkin's paper. And it's about the pair of classes themselves. And the delta approximation is whenever A subset of M is a set in N and A intersect A is in M for any A and M of size less than delta in M, then A is in M. Okay, so it's about the relationship between M and N. And then also the cover properties. You can read that. Okay, so the main point is that if we can lift and we have the delta approximation and delta cover properties, then the Mitchell rake stays the same. And so this is the part of the preservation part. Okay, we still want to destroy things. So, okay, next slide. Okay, So the big idea for softly killing measurable cardinals is that we start in a ground model, and it's this measurable for this the proof where we're just making the cardinal a rank 1 measurable in the forcing extension. So you have this measurable cardinal. He's got some kind of ranking. We want to lift the embedding. Okay, so I feel like I should put in that slide. We want like I should put like a new J there in the forcing extension. But basically, in the forcing extension, we need to lift this embedding so that in the forcing extension we still have this embedding that realizes that the cap is measurable. Okay, I should add that. So the main things we need when we're doing a lifting is we need the diagonalization. This is again Hampkins. This is from Hampkins' book, Forcing in Large Cardinals. And we basically need two things that we're going to use a lot, and that's the diagonalization criterion. The diagonalization criterion gives you a generic filter. And also it gives you a generic filter that contains some element that you'd like to include, and that's going to be really helpful. And then the lifting criterion actually allows you to lift the embedding. Okay, so the diagonalization criterion, this is all in quotes. This is from Joel's book. That picture is just sort of just an interpretation of the words that are in. Okay, so diagonalization criterion, if P is a partial order in a model M of set theory, and for some cardinal theta, the following are satisfied. So it's about this closure properties. And we do have, like for measurable cardinals, something like M to the kappa is a subset of M. We also have the forcing is less than or equal theta closed in M, and M has at most theta plus maximal antichains for P. Then for any P and P, there's a M generic filter H subset of P with P as an H. So we get that P in the generic filter, and we're going to need that because we want to include certain master conditions in our generic filter. And the lifting criterion is you have a J from M to N, and you want to lift it to a J from M of G to N of H. And so M is a subset of M of G, and N is a subset of N of H. G is a subset of P, the forcing P, and H is a subset of J of P. Okay, and so in order to lift, the lifting criterion is that J image G is a subset of H. So it's showing how these generic filters work together through J. Okay. I think it's nice. There's like a proof for why the lifting criterion works, and that's nice. Okay, maybe I could mention it or include it at some point. Okay. Okay, so this is the theorem. This next slide here, this is the basic theorem for killing measurable cardinals softly. If kappa is a measurable cardinal, there's a forcing extension where order of kappa is 1. And so the forcing will preserve all measurable cardinals and not creating new measurable cardinals. There's a lot going on. This is just the very, very, very basic idea. One thing is you have a measurable cardinal. One thing we're doing right away is that, okay, this kappa might have a big ranking. We don't know. We're going to choose a J from V to M where M is not, M thinks kappa is not measurable. So you have all these elementary embeddings, and kappa might have a high ranking, and you could definitely find one that like witnesses that high ranking, but you could also find one where kappa isn't even measurable in M. And so we're going to choose that. And then we're going to force the GCH, or force at least 2 to the kappa is kappa plus. For this forcing, I think for the general, we need to force the GCH, but we can always do that. It's no problem. Maybe it's already there. And then we have a forcing P, which adds a club of non-measurables at inaccessible stages less than kappa. Okay, so we've got kind of two things going on. But this forcing is actually in the future is going to help us with the lifting. Because of this forcing, it's going to allow us later stage the Q to lift, something like that. Okay, so we're going to lift this embedding. We'll use I think we use the diagonalization criterion and to get these to get a generic filter for M of J of G, and we also have this thing where we factor J of P as P star Q dot star P tail. Now Q dot is the forcing at stage kappa. Okay, so we first lift through P. This add a club of non-measurables at inaccessible stages. Adding at these inaccessible stages also gives us this like closure, so we can do this diagonalization criterion. Okay, so So we lift through P, we get to V of G, the bedding has been lifted. At this point, we haven't lost the ranking of the measurable cardinal yet. But now we're adding a club of non-measurables to kappa. And not only that, we have this like, we can, because of the way the diagonalization criterion works, we can actually get that this C is an element of G star. G star is a subset of J of Q. And so J of Q, let me, you guys, let me just say this real quick. The forcing J of Q is the forcing to add a club of non-measurable cardinals to J of kappa. We need an M of J of G generic filter for J of Q. Okay, so we sort of work on that. Okay, so we get that this C is a club of the C is a club in kappa of non-measurables. Okay. Okay, I do wish I had a better like this, and then that's why this all makes sense. Okay, I feel okay. So it's I can't include all the details, and that's sort of. But I need to work on my explanation of this. Okay, so eventually we lift through Q as well. We use this like diagonalization criterion. We use. I just feel like the forcing itself is helping us to lift through Q. Eventually. Okay, also, kappa was not measurable in M, so it's also not measurable in M of J of G, and this has to do with the, like, no new measurable cardinals. And so eventually we end up in V of G of G. And in V of G of G, the embedding has been lifted. We have all these generic filters for these M parts, but in the end, it only has rank 1 because you added this club of non-measurables to kappa. Also, because we started in with this J from V to M, where M thinks kappa is not measurable. Okay, so the combination of those two is what does it. Okay, so in V of G of G, kappa is measurable, but it doesn't have any higher special ranks. Okay, the main two theorems for measurable are, first one, for any V model, so next slide, Z of C plus GCH in any ordinal alpha, there's a forcing extension V of G where every cardinal kappa above alpha in V of G has that the order in the forcing extension is the min of alpha and whatever order it was. So it's just that you can't dip. If your order of kappa is like, let's say 5 in the forcing extension, it's not going to go up to order 7 or something. But it could go down to like 3. And then the main theorem for measurable, for order of kappa greater than kappa, we have to use representing functions, which I should talk about, but for this I'm not going to. For any V model Z of C plus GCH and any F from ord to ord, there's a forcing extension V of G where if kappa is measurable and F restricted to kappa represents F of kappa and V, then the order in the forcing extension of kappa is the min of whatever it was in this F of kappa. Okay, so it's not going to go up, but it can go, if it was kappa plus 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 in V, then it could be just kappa plus plus in V of G. Okay, and then, so was that it? Okay, 1, 2, 3, 4, 5, 6. Okay, that's it. Okay, so I went way over the time, but thanks for listening, you guys. And I guess I was at the beginning, I was like chatting. I want to talk about my work and stuff. Like I'm gonna start a job, so I'm teaching like professor job, and now I have like more like I have to go in every day, and I'm hanging out with adults. I like it. I don't have like a class on my own. I'm gonna be tutoring. Anyone can come in for any of the classes, and I'm looking forward to that. But it is like a everyday kind of job, like. Not like teaching isn't an everyday kind of job, but it's like I have to actually be somewhere at a certain time. Okay, anyway, so I'll see you guys tomorrow, though. I'll see you tomorrow and I'll see you Friday because I got to finish this up. And then after that, I'm not sure. But thanks so much for listening. Thanks for hanging out. See you soon.